Hi everyone, today let's solve the problem number 881 boats to save people. So what the question states here, we are given an array people. See here, we are given an array people where iterated value of the people is the weight of the ith person, where iterated value of the people is nothing but the weight of the ith person. So here this one they are speaking of, this is weight of the ith person, which means weight of the zeroth indexed person, and this is 2 is weight of the one indexed person, right? So we are given an array people where people of I is the weight of the ith person. This is nothing but the weight. In short, this is nothing but weight basically, right? So each boat can carry at most 2 people with a total weight less than or equal to limit. So here this the value of this one should be less than or equal to limit. People array, when we sum up the people array, the elements in the people array, so this should be less than or equal to ith, less than or equal to limit, sorry, less than or equal to limit. So that's the condition they have given here. So each boat can carry at most 2 people with a total weight less than or equal to limit. We need to return the minimum number of boats that that is needed to carry everyone. So this is very important. We need to return the minimum number of boats that is needed to carry everyone. Each person has only each person can only be on one boat. Each person can only be on one boat. So this is very important, right? So again I'm telling, each person can only be on one boat. So this is the condition they have given, right? I hope this part is completely clear. So this is the problem statement. So let's discuss the examples and then let's go with the approach and complexities before writing the code. So let's come to the first example here. They have given the people array here, this one, 1 comma 2, and limit they have given 3. So there is only one bot needed, 1 comma 2. So this will lead to 3, right? So 3 is less than or equal to 3 here in this case. So in this case the output will be 1. There is only one bot needed. So here in this case we have people, this one, 3 to 2 1 people array, and limit is again 3. So we need 3 bots here. One is 1 comma 2, which is less than or equal to 3 is the condition, right? Less this one, people less than or equal to, people's weight less than or equal to limit. Basically 1 comma 3, 1 comma 2 will lead to 3. So 3 is less than or equal to 3 basically. Yeah, this condition holds good for this one. And another one is 2, which is less than the limit. So this one also we can consider, either we can just consider 2 as well, right? So this is one thing. And one more thing, we can just consider 3 as well directly. So this one, so these are the 3 bots that is required. 3 bots, 1 comma 2, 2 and 3, right? So let's come to the final example here. 3 5 3 4 and limit as 5. So here either we can consider 3 and another 3 which is lesser, and 5 directly 5, wait, so that one, and 4 also we can consider, these 4 things, right? So I hope this part is completely clear, right? I hope this part is completely clear. So I hope the question is completely clear. They have given us wonderful examples just for the sake of understanding. So next, what shall we do? Let's do one thing. Let's quickly discuss this one. What do you call approach part? So let's quickly discuss the approach followed by the complexities, right? So here, let's consider the first example. Let's go with the first example. Just give me a second here. Let's go with the first example, this one I'm speaking of. So we have the people array. Within the array we have 1 comma 2, and the limit we have here is 3, right? So here first we will sort the array. In this case it is already sorted. So when we come to the second we have to consider all the edge cases, right? So we have to consider all the edge cases. In this case it is already sorted. First we will sort the array. So here for the first example it is already sorted. So this remains as it is, 1 comma 2, and we'll be making use of the left pointers, left pointing to the first index and the right pointing to the last index, right? So in this case we have only 2 elements, and left is pointing to the 0th index and right is pointing to the last index. Last index means here in this case people dot length minus 1, right? So people dot length minus 1. So this is fine. uh, Left equals 0, right equals 1. So this is the heaviest and this is the lightest accordingly with the question. This is fair, right? So we will check if the people of left plus people of right is less than or equal to this one. What do you call? Mm, limit. So here in this case 1 plus 2, people of left and people of right. People of left we have this one value 1, this one we are considering, and people of right we have the value 2. So 1 plus 2 is less than or equal to 3. That's what we need to check, right? So 1 plus 2 is less than or equal to 3. Yes, 3 is equal to 3. Basically 3 is equal to 3. Let's give the comparison operator here. Let's make use of the comparison operator. Yes, 3 is equivalent to 3. So we have to display yes here in this case, means we have to pair them in one bot. We have to pair them in one bot. We have to move both pointers inward, right? So then the next step is we have to move the both pointers inward. So we have only two elements, man. So only one bot is required. So for I insist you to try out with the second example and the or the third example, right? So this is how we got, there is only one bot needed, right? So this is the only one condition, there is only one bot needed, right? So I insist you to try with the second or third example, so that you understand the question clearly. You have to get the output 3 bots are required in this case. You have to get the output 4 bots are required here in this case. So yeah, this is it for the approach. As we are completely familiar with the approach, let's discuss the this one complexities quickly. So what's the time complexity here? The time complexity would be big of n log n, because the first step that we discussed in the approach itself is sorting, and sorting will be the dominant factor here. So the time complexity would be big of n log n. And what is the space complexity? You would have already you would have already guessed that it would be big of 1, because we'll not be making use of any extra space rather than this one. Two variables, one is left and another one is right. Right. So the space complexity would be quite obviously big of 1. We are just sorting in place and no extra space is being used. So the space complexity would be big of 1, quite obviously. The time complexity would be big of n log n, and the space complexity would be big of 1. Right. For the code that we'll be writing in the future. So I hope the complexities part is completely clear. Now, as we are familiar with the approach along with the complexities, we are good to write the code. Let's start writing the code. So let's articulate the same approach, same things that we discussed in the approach step by step. Now, first thing what we did in the approach. So first thing was the sorting, right? So we have to sort the array so that we can pair the lightest and the heaviest people, right? So I can just articulate in this way in the form of code. So I can just write arrays dot sort of, let's pass the people, nothing but the people array, right? So we are sorting the people array itself, right? So then we have to consider two pointers, means the left pointer that is pointing to the lightest person, and the right pointer that is pointing to the heaviest person. So let's make use of the two pointers here. Left, mm, let me initialize this one to 0, and the right pointer, let's go with the, let's initialize this one to the last index, nothing but people dot length minus 1. This is fair. The next one is we have to use the this one counter for boats that is being used. So how many number of boats that can be used, that itself we have to find out, right? So here in this case int boats equals 0. This is one thing. So this is fine. So the next step is we have to loop until all the people are considered. Means here this will be while left less than right. So as we are making use of the this one two pointers, left has to be less than right. So here if the lightest plus heaviest can share the board, then we have to move the both pointers, means move inward, right? So if lightest plus heaviest can share a board, then we have to move both pointers. Let's write the simple if condition for that. So if people of left plus, this was the second step in the approach if you remember, people of right less than or equal to limit, then what we will do, limit plus plus. So let's increment the limit. So let's do one thing, we can always move right pointer, means heaviest person boats the boat, right? Always. So this will be right minus minus. So because I'm telling this one again, heaviest person boats the boat. In this case 1 comma 2 we had two heaviest person. So in this case we need to always move the right pointer, right? So again, after sorting, after sorting, one thing for sure, when we sort in the ascending order, we will be having the lowest value at the starting and the highest value at the end, right? So we have to always move the right pointer, quite obviously, because the heaviest person boards the boat, right? So here in this case we are decrementing the right. That is the reason we are decrementing the right. And the next thing here is one boat is used in each iteration, we know this one. So let's do one thing, let's increment the boats. This is fine. So the final part here is we need to return the boats, means we have successfully calculated the total number of boats that is required, right? So that's what they have asked in the question. Now we need to return the total number of boats itself after the calculation. So here this will be return boats, sorry, yeah, return boats itself we have considered, right? Counter, this one, yeah, this is fine. Let me copy this one, paste it over here. So this is fine. This is it for the code, simple, right? So let me format the code once and let me hit the run button. I hope this works, man. Let's see. Wrong answer. Output 3, expected 4 for the test case 3. And for this one, this works. This also works. For the third case, it is failing. What 3534 we are having? Limit 5, but somewhere we have done wrong. Let's see where we have done wrong. So yeah, you can clearly see here in the line number 5, in the line number 9, sorry, uh, we have to give if while the left is less than or equal to right, not left less than right, right? So I had given left less than right. So that is the reason we were getting the wrong this one output. Mm, let's see. Let's check whether this works now. Still we are getting the this one. So what mistake I have done here? People of left less people of right. This is fine. It has to be less than or equal to limit. Means if lightest plus heaviest can share the board, then only we have to move the both pointers. This is fine. So yeah, we have to increment the left pointer, not the limit. So I don't know why I had considered the limit there. Right. So this is fine. I got confused, I think. So let me hit the run button again. So this is the reason it was getting failed, basically. So now you can clearly see here the sample test cases are getting passed. So let me hit the submit button quickly. So you can clearly see here all the test cases are getting passed. Means the code works absolutely correct in this case, right? So one thing, I hope the solution part is completely clear along with the complexities and the approach. For now, this is it. Thanks for watching, guys.